Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about doing a check on an oceanographic surface mooring in shallow water. So why this is significant is if you're working with a fairly shallow water mooring, you may be able to jump over the static analysis and go straight to dynamic analysis. I'm going to use the Datawell 200-meter template mooring. Now, 200 meters is probably a good threshold to do a static check first, but less than, for shallow waters, like really particularly for much shallower waters, you might be able to just go straight to dynamic, and I want to show you what that process looks like. So when we do, typically we would start off with a static analysis, but in this case we're going to jump straight to dynamic. Now it creates the ProteusDS simulation toolbox files. The downside of this approach is that you're going to start off with just a straight diagonal line for the mooring, which is not exactly a realistic profile. However, for the shallower the mooring, the more rapid it will relax into the profile, and in particular, it'll do that even faster the bigger the waves are, especially for that water depth. So we don't have to do anything else other than just turn on ocean waves. We're going to use the irregular John swap spectrum. And we've been using 5-meter significant wave height on a few examples. We're not going to change anything else. It starts off with a default of 60 seconds. We may want to run that for a little bit longer, but for demonstration purposes, I'm just going to show what this looks like. Now remember that wave ramping is on by default as well, so the first 10 seconds is ramping up this sea state. So why you might want to do this is in shallow water, a static solver, sometimes it can struggle just because of how tight the water depth can be. This might be more of an issue in, 10, 20, 30, 40, 50 meter water depths. The other thing is it may just be faster for your workflow to jump straight to the dynamic analysis because you get a reasonably good characterization of the loads and just get a sense of what's going on. So we'll let this run for a little bit and then check out the results. All right, so some time's passed. We've got 60 seconds of simulation, and I want to see what the results look like. So we'll open PostPDS and just click OK for loading all the default data. And here's the world, and our Datawell moorings in here. If we double click on it, you can kind of zoom in on its location. I like engineering view to just get a view of that whole mooring. So now remember, this is the straight line starting point for the mooring. And we can play it back and watch the waves slowly start to ramp up over the course of 10 seconds to our 5-meter significant wave height. But I kind of want to get an idea of like how is the mooring behaving over time, and you can start to see the mooring relaxing to that profile, but it's going to take a bit of time to do that. And you can grab the slider and kind of move things along a little bit. So if we go to plot tension versus time, and element 1 will be right at the top where the buoy is, there's going to be some sort of growing tensions over time as it relaxes, but you're actually starting to get a good characterization of what's happening. So for something a little bit deeper, like 200 meters, it's good to do a static analysis, but for shallower moorings, 10, 20, 30, 40, 50 meters, you can sometimes jump straight to dynamic and get a good characterization. And even now, we're starting to get an idea of what that's like for this particular mooring for those dynamic loads. So sometimes it can be a little bit faster. Anyway, that's what I wanted to show, an alternative workflow jumping straight to dynamic with shallow water oceanographic moorings. Thanks for watching.